2.8 is modeling the variation. And there's really two main types of variation that we're going to do. There's a third type that's just an extension of one of the first two. So there's three actual types, but there's two big main types that we're going to look at. We'll go ahead and get all three. But again, there's the two big ones, and we'll get the third one. First one we'll do is direct variation. And direct variation, the biggest thing with direct variation, this is always between two variables. And basically, here's what direct variation is. If you raise the price, if we're talking about price-wise, if you raise the price on one variable, it increases the price on the other variable. Like right now, when the price of corn goes up, gas prices go up because we're putting corn in our gas. And you flood the market with iPhones, and the price of iPhones tends to drop because there's tons of them out there. So that's your direct variation, is that the variables act the same way. We'll just say that the variables move in the same direction. And the one big equation that goes with direct variation is y equals kx. And the k value, because x and y would be your two variables that you're going to talk about. The k value, that's your constant of variation. That is the one thing that's the same no matter what you do to the prices of everything that's going on. The best example I can give you of an example of direct variation. Anybody remember the formula for area of a circle? Circle, so it's got to have pi, right? So it's pi r squared. Okay, so there's your two variables, your area and your radius. The one thing that's always the same no matter what you do with the circle is your pi. So in that case, your k value would be your pi, which again is about 3.14. So no matter what you do with any circle, anywhere, any point in time, you're always going to use 3.14. If you increase the radius, you have to increase the area. If you decrease the radius, then you have to decrease the area. So that's the best example that most people know about what direct variation is and kind of how it goes together. Okay, the second type is inverse variation. And with inverse variation, it's also between two variables. And the best way to say, I guess, inverse variation is because they're inverse, they go in opposite directions. So before we're saying the variables move in the same direction, this time we'll say that the variables move in opposite directions. I think I misspoke about the iPhones a minute ago. I think I was actually saying that one actually would be an inverse variation, because if you have, well, gas, take for example. The more gas you have, the more people producing gas, it drops the price of gasoline. If you've got all kinds of different suppliers and different people that build iPhones for you, then all of a sudden you'll see the price of iPhones drop because people can make iPhones like crazy. We'll be paying $1,000 more for an iPhone. So inverse variation is they're going to react in two opposite different directions when you go through that. And since it's inverse and it's basically opposite, we're going to do the opposite of what we did up here. Instead of multiplying k times x, we do inverse variation. you're going to do y is going to equal k, but instead of multiplying by x, you're going to divide by x. And again, k is still your constant of variation for that thing. And then the third type is joint variation. And joint variation is basically just an extension of direct variation. Now it is and it's not. Here's what makes it to me when I see this one to realize it's the extension of direct variation. Because with direct variation you're multiplying the things together. Joint variation, it's the same thing. You're going to multiply the different things together, but now instead of just having one variable, you're going to have two variables on this part. So to me, when I say that it's just an extension of direct variation, in that you have two or more variables, or that you multiply two or more variables together. And the biggest thing you're going to do with these is they're going to give you, you've got two types. One part, they're going to give you some numbers, have you plug in some different things to find out what the constant, what the k value is. The other part, they're basically going to have you just rewrite one, change it from a word problem to an equation, or go from an equation back to a word problem, and then have you find some numbers with it. So when you're breaking these down, here's the biggest thing we're going to do. Let's just give you a kind of a setup here. So they're going to ask you to write an equation and solve for the missing variable. Now, here's the big thing when you're going through these. Anytime you see the word varies, you can take the varies part out and replace it with equals k. That's always going to be. So they're going to tell you that this thing varies, and then after that they're going to tell you whether it's direct or whether it's inverse, or they'll tell you if it's jointly when you're going through these. But the key thing is that anytime you see the word varies, you're going to replace that with equals k. And they should just give you variables past that point when you're going through the parts on this one. So they'll give you one like this, and we'll change up in a minute where we don't use y and x. We'll use some different variables. They'll tell you that y varies directly with x. So they're going to ask you to write an equation for it, and then after that, they're going to give you some values for this thing. So they'll tell you that y equals 65 when x equals 5. And then you're going to find y when x equals 12. And you can basically look at it as every sentence is it's like a different part to the equation that you're looking at. When you look at the very first sentence, that's going to be your setup for what the equation is going to be. So you've got y, and as soon as you see the varies, that's your equals k. And then the direct tells you, the next word after the varies, whether it's direct or inverse, tells you where to put the next variable. If it's direct, it goes directly beside it. If it's inverse, then it's going to go underneath it. Okay, once you've got that first, they give you the first sentence, that's basically you taking whatever sentence they give you, writing out the equation that goes with it. Again, there's your varies, and that's your equals k. Once you've got this part of the equation done, well, basically you're going to take the second part here. They tell you that y is 65 and x is 12. Take those two numbers and plug it back into the equation. you've got 65 equals k times 5. And when you're taking that second sentence, you're finding out what the k value is. You got to figure out what's constant in this equation that we're going to work through. What's, if it's pi, we know it's 3.14. It could be it's the price of gas. It could be whatever it is that they're doing. You've got to figure out what's the constant that's in this equation that we're going to work through every time. So we've got 65 equals k times 5. To solve that one, we're just going to divide both sides by 5. So those cancel out. 65 divided by 5 would be 13. Well, halfway. Now that you've got the k value, which, again, they're asking, that's the answer we need, but it's not the final answer. It's that halfway step. Now that you know what the k value is, that's your constant variation, they give you one more variable to plug in, so now for a second time, you're going to start with that same equation. You've got y equals kx. But now they tell you, for the last thing here, go back and find y when x is 12. So we're going to plug in 12 in for x. But you're also going to take this k equals 13 and plug it in as well. So that y would equal 13 times 12, and that should be 156. And that will be your final answer. So your k value is like a halfway answer. It's kind of like when you're going on vacation with your parents. It's all right, everybody out of the car, and like, over here? No, we're halfway. We're just getting out for a stretch break. Like, oh. So when you get the k value, you're halfway there. Now you got to get back in, plug it back in to find out what the missing value is going to be from there. So once you get the equation from the first sentence, you're going to use it twice. Once to find the k value, and then a second time, then go back and take the k value and then the last remaining value they give you to go back and plug it in to find out what that missing value is. Okay, so for example 2, we're going to do y varies inversely as x. And we'll do y equals 12 when x equals 5. So let's find y when x is 2. All right, and again, taking the first line, take the first sentence out. You've got the y equals, again, the varies basically that's your equals k part. The next word after it always tells you what to do with the next variable. If it's inverse, that means that x has to go underneath the k value. All right, so if it's inverse, we know that y is equal to k over x. Now we've got these two values to plug in. So the 12 goes over here with the y value. The x goes underneath the k. And this one's a little bit easier because to find the k value, you just multiply these two numbers together. So k is 60. Okay, and again, halfway there, because now we've got the k value. So now we're going to take, once we've done that with the first time, the second time is we're going to use that same equation again. But now we know that k is 60. And we were given the x value of 2. And 60 divided by 2 is 30, and that's the final answer that we're looking for there. Okay, and the first couple examples they give to you, they'll be pretty easy, pretty straightforward. Not a whole lot to it. Just a direct equation or an inverse equation. After they get you through the first couple ones and you got your feet on the ground, then they start to bring in a few more variables, throw a few more words at you. So in this case, we're going to go y varies directly as x and inversely as the square of z. And then your values come in. You get y equals 20 when x equals 50. And z equals 5. Find y when x is 3 and z is 6. And if these problems are set up correctly in the homework, they should hopefully give you a checkpoint that you'll put in the first step first, that they should ask for the equation, hopefully. And you'll write in the equation what you think it is, and then you'll check it, and they'll say either yes, it's right, or no, it's wrong. If it's wrong, then you go back and fix it, tweak it. Hopefully they'll let you do that, because if you don't have the right equation, there's a very slim chance that you're going to get the right answer. So hopefully that'll kind of be a checkpoint along the way. Just someone's answer? Okay. To me, that would be where they should ask for it. But anyway, that's me and not them. All right, so the very first thing is you got to write the equation. So you got y varies, that's your equals k. The direct part goes with the x on top, and the inverse part means that's going to go on the bottom. And it's one of those easy little things that's sometimes, again, if you get in too big a hurry, it's not just z, it's the square of z. So it's z squared, and sometimes people will put a square root there. So I didn't say square root. It's just z squared. So the square of z is, there you go, z squared. Okay. And once you've got the first sentence set to get the equation, now you're going to the second sentence to plug in the numbers to figure out what the k value is going to be. So y is 20. You're going to figure out what k is. X is 50. And don't forget that when you plug in the 5, the biggest thing I've seen people make on this one, especially test problems, is they'll put in the 5 and they'll forget to square it. So after you put in the number there, make sure you go back and do 5 squared. So this one is 20 equals k times 50 divided by 25. And 50 divided by 25 is 2. So it's k times 2, so we've got to go back and divide both sides by 2. So then our k value is 10. Okay, now, if we're doing these on a test question, if we're doing paper, pencil in class and going through these problems, that's the little things I'm going to look for. Okay, did you give me this equation first? Okay. Then work through this one. Did you get the k value next? And again, if you missed one little sign along the way, if you forgot to do the 5 squared, I'll watch it and kind of go through and hopefully give you some partial credit as we're going through those. And then last thing is, since that was our first step, we'll come back and do this again. But on the last step, we're going to use these values. And also, k equals 10. So now we've got y, which we're going to figure out. K is 10. X is 3. And z is 6. And again, make sure you do 6 squared, because that one seems to always be the one that kind of sneaks up on you. So that is 30 over 36. That one doesn't simplify down to a whole number, which is okay. But in that case, you can divide both of those by 6. So that then y would equal 5 over 6. Got to be in simplest form, yeah. Now, I do know that if you put 30 over 36 in the homework, they'll count it wrong, but they'll give you that hint of saying, okay, you've got the right answer, but you need to simplify it, which is better than it used to be. It used to be it was just wrong and you didn't know why. So they have gotten better with the online homework about giving you hints along the way. Okay, let's do one more with a joint variation just so that you've seen it. And then we've got a couple of everybody's favorite kind of problems. We'll do a few word problems. Okay, we'll make this one kind of short. Y varies jointly as x and z. So y is equal to 25 when x is 2 and z is 5. Find y when x is 8 and z is 12. Okay, so we've got y equals k, and that's the part that'll always be the same. It's always going to be the first variable equals k, and then from there just figure out whether they need to be top or bottom. And again, joint is just an extension of direct variation, so those things are all just multiplied together. So it's y equals kxc. Okay, then we use the next line to find out what the k value is. X is 2, z is 5. So 25 is equal to 10k. Divide both sides by 10 so that k would be 2.5. And lastly, we'll take the 2.5 here, and then the last two values from that last line, plug it all in, find the final answer that we're looking for. So we know that k is 2.5, x is 8, and z is 12. Okay, 2.5 times 8 should be 20. And then 20 times 12 is 240. Okay, and as far as the basics of everything goes, that's the whole big thing that you're looking at. That, again, direct variation, you're multiplying. Joint variation, you're still multiplying, but sometimes the numbers, because you're multiplying two variables together, they may fluctuate up and down as you're going through those. Inverse means you got to divide by the number that they give to you. Okay, and then the last thing they're going to do is still just an extension of those, but it's going to be a little bit more word problem than just here's a number. Here's basically your word problem. We'll do one, maybe two of these. So the height of all balances varies directly from which it is dropped. tennis ball dropped from 12 inches, bounces 8.4 inches. From what height? Does the ball need to be dropped? If it bounces 56 inches. Okay, and again, it's still kind of that same basic thing. The very first sentence tells you what you're going to do with your equation. The height the ball bounces. So you got to figure out how you want to call that part. Varies directly from which it's dropped. Okay, so I would say, and you can, because it's just the two variables, you can kind of word this how you want to here. But I would say, if D is the drop height, that's got to vary directly with the bounce height. So that's bounces and this is drops, maybe. And you can use, and here's the thing, you don't have to do any variable with this one, it's just going to ask for the answer, so you can set this up ever how you want to. But they're going to vary directly for this part of it. So the drop part on the next one here, it says is 12 inches. And then the bounce part is going to equal 8.4. So we'll use that to figure out what the K value is. So the K value would be 12 divided by 8.4. And that comes out to be 1.47. Sorry, 1.42857. Goes a little bit farther, but if you want to go out a few more, and again, it keeps going, but that's the basic idea of what we've got there. All right, and then the last line gives us the next number that we need. In this case, it's going to bounce 56 inches, so that means our B is 56. So we've got to figure out how high it was dropped from when K is this 1.42 number. We'll just round it off there, times 56. Okay, and they conveniently picked some numbers that when you do that 1.42, if you leave this whole thing in here, it comes out to be 8. Okay, when I first read this problem, I was thinking feet. I was like, 56. And I was like, whoa, and it's like, oh wait, that's 56 inches. That's only 4.5 feet. Because I was thinking, when I first saw this, I was thinking feet, and I saw it, and I was like, man, that's at some point in there, the numbers eventually will kind of even themselves out, and gravity starts to have a little bit of effect to it. But